So when we look at circuits, we can give names to the alignments of the certain components, but for today we're just going to be looking at the resistors. So we have series and parallel. What do these look like? So for resistors in series, you're going to see resistors that are one right after the other. So we have one resistor and then a wire with no breakpoint in between. It just leads right on to another resistor. And for parallel resistors, we're going to see something more like this. So we have a wire and a resistor, and there's pretty much a breakpoint here that connects to another resistor, and that's what parallel resistors look like. So the naming for these is actually pretty intuitive because, as you can see here, the resistors form parallel lines with one another, and when I say that something's in series, I like to think of it as one right after the other. So obviously these resistors are just connected one after the other without any breakpoints in between them. What if we had a section in our circuit though that looked something like this? So we have a wire, it splits into two sections, and we have resistors right after that split, and more resistors like this, and they come together to form that one wire leading down. So actually, these two resistors, since they're leading one right after the other, are in series. It doesn't matter that there's a little bend here. It's just another way to represent the resistors in series with one another. So we can actually change this diagram a little to an equivalent version where it still splits into two paths, and we still have our two resistors on the left side and two resistors on the right side. And they come together again down here. So you can more clearly see now that these two resistors are in fact in series, and these two resistors are in series. And actually the combination of these two resistors and these two resistors are going to be in parallel with each other because they form parallel lines. So going back to combining the resistors into one, you can actually do that by adding the resistance values of each of them. So the total resistance of resistors in series is just going to be the resistance of the first resistor plus the resistance of the second resistor plus whatever other resistors you have. So combining resistors in series is not that bad. All you have to do is find the resistance and then add them together. So let's say that this resistor has a value of 50 ohms, and this resistor has a value of 25 ohms. So these two can combine to make an equivalent resistor of 75 ohms. And it's a little different for the parallel resistors though, because instead of simply adding all of them, you're going to take the reciprocal of all of these variables here. So 1 over the total resistance is equal to 1 over the first resistance plus 1 over the second resistance, and on and on and on. So let's actually try to find the total resistance for the resistors in parallel if both of these resistors on the right have the same values. We know that the combination of the resistors on the left is equal to 75 ohms, and same goes for the right because they're all the same values. So we now have this simplified into two equivalent resistors, and what we can do now is take the resistances of these two and use them in the parallel equation to try to find the total resistance. So we have 1 over the total resistance is equal to 1 over 75 ohms plus 1 over 75 ohms. And I know that simplifies to 2 over 75. So if we take the reciprocal of 2 over 75, then we get 37.5 ohms. So our total resistance is going to be, so our subtotal is going to be 37.5 ohms. Notice how the total resistance of these two parallel resistors is actually smaller than one resistor itself, while in series, the total resistance is going to be bigger intuitively because you're simply just adding the resistance values.